section 4.4, and I'm going out of order a little bit. I'm going to do the problems between 13 through 30 first, and then go back and do the first couple sections of problems. These problems probably kind of illustrate the concept slightly better than the concepts in this section, slightly better than the beginning problems. So I want to do them first, specifically because they can be done on a calculator, and that way I can show you the connection between what you could do in your calculator and what you can do by hand. So these problems want me to, if a problem has a negative exponent, first change any negative exponents to positive. For each of the problems between 13 and 30, ultimately I want to be able to get an answer by hand rather than using my calculator, because the by calculator will not work when you have variables. So first, if there are any negative exponents, make them positive. That's not going to matter for the problem that's staring at me, because it has nothing but positive exponents. And this is going to involve using the tricks that we learned in section 4.2. So that's the first thing I'm going to do. And then write with a radical as opposed to a fraction exponent, and then reduce. So the first problem I see is 16 to the 1/2 power. Absolutely not hard to do this on my calculator to figure out what it actually equals. So if I had no idea what this equals and I owned this calculator, I can go 16, make an exponent, make the exponent a fraction, type in 1/2, and my calculator will tell me that this equals to 4. So ultimately, I want to write 4 for an answer. To do the steps involved in this problem, are the steps that were involved, I can skip the first step. Second step, write with a radical. Any fraction exponent can be changed to a radical. And when we're writing a radical, we need an index and a radicand. The denominator of the fraction exponent is going to be the index. The rest is going to be the radicand. So the denominator of the fraction exponent will be the index. The rest will be the radicand, which means the stuff that goes under the radical. So I'll give you a second to digest that. So I look at this problem. It has a fractional exponent. Anytime I have a fractional exponent, I can make a radical. So I'm going to write, I call this a radical. And a radical has an index and a radicand. In this problem, the denominator of the fractional exponent becomes the index, and everything else goes under the radical, becomes the radicand. So that is an unsimplified version of writing this as a radical. This has two things written that don't really need to be written. Never do I need to write an exponent of 1. If the exponent is 1 and I don't write the exponent, 16 and 16 to the first are the same. Also, 2 was the index that's assumed if no index is written. So 16 to the 1/2 power is the same as the second root of 16 to the first, which is the same as the square root of 16. And I know the square root of 16 is 4, and my calculator told me that this is supposed to equal to 4. In general, we usually say the 1/2 power is the same as the square root, because 16 to the 1/2 power reduces to the square root of 16. Usually, I can't think of a case when it's not the case, an exponent of 1/2 changes or reduces to a square root, as opposed to a cubed root or a fourth root or fifth root. So when I see 1/2 power, immediately when I saw 16 to the 1/2 power, I thought, oh, that's the square root of 16, because 1/2 power and square root are interchangeable in my mind. All right. Ooh, I forgot to use my blocking paper here, which makes this thing bleed through. So I'm gonna do 16 on my calculator so I understand what the answer is. So I'm gonna go negative 25, do an exponent, fraction exponent, type in 1/2. I definitely see 1/2 power, so I think square root. My calculator will know that, and my calculator, it knows what to do with the negative. So ultimately, this is supposed to equal -5. This problem's a bit different than the last problem because of that negative. I can still kind of see a square root because the square root of 25 is 5, and 1/2 power is a square root. When I go to write this in its radical notation in my attempt to simplify this to -5 without having to use my calculator, that negative, because it's not in the parentheses, belongs in front of the radical. If the negative is not in a parentheses, it goes in front of the radical. If the negative is inside a parentheses, it goes under the radical. So I'm not sure. I have problems. So had this problem said this, if the problem was this, when I'm rewriting it, I'd treat the negative differently. The real problem 16, when I go to write this, first of all, it doesn't have a negative exponent because that 1/2 is positive, so I'm skipping making the exponents positive because it's already positive. I'm going to write a square root symbol. The 2 is going to be the index. The 25 to the first is going to be the radicand, and the negative is going to go in front of the radical as opposed to under the radical. If this was the problem, which would be give me some sort of error on my calculator, this would be the second root of -25 to the first. So you have to be careful when there's negatives, when you're taking a problem with a fraction exponent and writing it as a radical. If the negative is not in a parentheses, it stays outside the radical. If the negative is inside a parentheses, it goes under a radical. So as I continue to try to get this to reduce to -5, I have the same situation that I had last time. I can still write this better. The index of 2 doesn't have to be written. So I'm going to write this as negative square root of 25. So this 2 and this 1 are both optional. I don't have to write an index of 2. If no index is written, it's assumed to be a 2. I don't need to write an exponent of 1. If no exponent is written, it's assumed to be 1. So this thing right here, the negative in front of this, really means -1 times the square root of 25. And I know the square root of 25 to be 5. So this whole thing's going to come out to be -5. This one, if I tried to do it, I'm going to get an error message on my calculator. This version right here, if I did -25, up arrow, fraction 1/2, because it's taking the square root of a negative number, and square roots of negative numbers are imaginary or complex numbers, so it gives me the error message because I'm taking the square root of a negative number, like when we're doing those tables in a section ago, maybe 2 sections ago. We got error messages. This would be one of those where you'd get an error message. It's not a real number, but not an issue. That's going to not come up until section 4.10. All right, next couple problems are getting meatier in terms of they're harder to do by hand, but they're not any harder to do at all. My calculator, I can blow right through this. Do 64, up arrow, fraction 4/3. Ultimately, I want to figure out how to say that this equals to 256, because that's certainly what it equals to. Well, to do that, I'm going to write it, do these rules. There's no negative exponent to worry about, so I'm not worried about it. But there is a fraction exponent, and fraction exponents could be made into radicals. The radical form of this is going to be the cube root of 64 to the 4th power, because the denominator of the fraction exponent becomes the index, so I get a cubed root, and the rest, the 64 to the 4th, goes under the radical. If I'm doing this by hand, you have a little flexibility. You could do the 4th power first, or you could do the cube root first. If I'm doing this by hand, then I have to know something, and what I really need to know is the cube root of 64. So by hand, first I will find the cube root of 64, and then I'm going to raise to the 4th power. The unfortunate thing is, if you don't know what the cube root of 64 is, and you have to go to your calculator to figure out what the cube root of 64 is, then it's just kind of pointless. You might as well have done the whole thing on your calculator anyways. But I know the cube root of 64 is 4, so I can do the cube root first, and then the 4th power second. Similarly, if I didn't know what 4 to the 4th power was and I had to use my calculator, it's not that much harder to do the whole problem than it is 4 to the 4th. But the 4 to the 4th power is 256. So by hand, or kind of by hand, I was able to create a problem that's equal to the original problem, and in 2 steps I was able to simplify it. Quite honestly, most students wouldn't be able to do one of these 2 steps, and they might as well have done the whole thing with their calculator. I'm just trying to prepare us for when we get to letters, because if this said x to the 4/3 power, well, and it was handy, I could write that as the cube root of x to the 4th, and later we'll learn how to simplify that, but not yet. So this is seeding how to do problems with letters, with problems I can double check with my calculator. So it's much easier to work with numbers than it is with letters. So doing a bunch of problems with numbers just to get you used to working with the rules of making fraction exponents into radicals. So I'll do 20, figure out what I'm shooting for. So I'm going to go 8 exponent fraction -1/3. So I'm trying to take this problem from the initial problem to 1/2 by myself without a calculator. This is the first problem where the rule that says if we have a negative exponent, we need to make the negative exponent positive. So that was the first kind of rule I said, and then write with a radical and reduce. So in section 4.2, we learned that if we have a negative exponent attached to an integer, we can make a fraction with a 1 in the numerator and change that exponent from negative to positive. So that's the first step in any problem in this grouping that has a negative exponent. Pull out the appropriate rule to change the negative exponent to positive. And once you have a positive exponent, we can write the problem as a radical. The 1 doesn't have a fraction exponent. It's not going to go under the radical. The denominator is going to turn into a radical because the 8 has a fraction exponent. The 3 is going to be the index, and the 8 to the 1st is going to go under the radical. I don't need to write an exponent of 1, so this is just 1 over the cube root of 8. And the cube root of 8 is 2. I can do that on my calculator, but again, if I'm going to do something on my calculator, I'm going to do the whole problem on my calculator. But that reduces to 1/2 because the numerator stays 1. The cube root of 8 turns into 2. Just like I say 1/2 power is the same as the square root, we usually say 1/3 power, this 1/3 power reduced to a cube root, is a cube root, or cube root. So when I saw 8 to the 1/3 power, I knew I was taking the cube root of 8. The cube root of 8 asks what number times itself 3 times is 8, and that's 2. So I don't always have change fraction exponents into radicals, because if I see 1/2 power, I just take the square root of the number. If I see 1/3 power, I take the cube root of the number. 22, let me figure out what it's supposed to equal to first. So I go 49 exponent fraction -3/2. So I need to get this reduced to 1/343. Just like the last problem, this has a negative exponent. If I have a negative exponent that applies to an integer, I can make the negative exponent positive by creating a fraction, and that term with the negative exponent be tossed down into the denominator with the positive exponent. Once I have positive exponents, then it makes sense to make radicals. If you make radicals with negative exponents, you're going to get something that I probably couldn't reduce by hand. So by hand, positive exponents are easier to work with. Now the numerator doesn't have a fraction exponent, it doesn't get a radical. The denominator, the 2 becomes the index. The 49 to the 3rd power goes under the radical. The index of 2 I don't need to write, so I could rewrite this as 1 over the square root of 49 cubed. I need to do 2 things. I need the square root and cube. For this one, first, I'm going to find the square root of 49. And then I'm going to cube. If I cubed first, the number would get insanely big. 49 cubed is too big. So when I do this, the square root of 49 I know to be 7. Once I take the square root, I don't write the radical anymore. I turn the 49 into a 7, but I haven't cubed. To get to my answer, the 1 in the numerator I already have, the denominator I have is 7 cubed, and the 7 cubed is equal to that 343. So I've constructed the best I can without a calculator the steps to get from the problem to the answer, but 7 cubed is not one I actually have memorized. I had to break out my calculator to get there. '24 and 26 have another negative exponent trick that you need to remember to do it by hand. With my calculator, I'd go 3/8 exponent fraction -2/3. This calculator just really is awesome. If you own a different calculator, you probably can't do these problems this easy. So this problem reduces to 12. That's what I'm shooting for. Has a negative exponent. I need to get the negative exponent positive. This negative exponent in the denominator, I'm going to move up to the numerator, and it's going to be multiplied by the 3. I won't get a fraction anymore. So this is part of the reason where I did section 4.2. I know there were problems just like this in section 4.2 that had negative exponents, but they weren't fraction exponents. But the idea of taking the negative exponent in this kind of problem and making it positive is the same strategy that we use in 4.2. Now I'm going to write a radical. The 3 doesn't apply to the fractional exponent. It's going to be in front of the radical. It's going to be 3 times, but I don't really need the times sign. The cube root of 8 squared. The 3 becomes the index. The 8 squared goes under. And for this piece right here, I'm going to do first, I'm going to do the cubed root of 8, and then I'm going to square. The 3 times that I have out here, that's the last thing I'm going to do. So simplifying this, the 3 times is going to stay out front. I'm going to do the cube root of 8. I know that to be 2, but if you didn't know the cube root of 8 is 2, you can do it on your calculator. So I'm going to get the cube root of 8. I still haven't done the squaring part, so I'm going to leave the square. Now I'm worried about orders of operations. Order of operations, it'd be wrong to say this is 6 squared. You have to do the exponent before the multiplication. So as I'm simplifying this, I do 2 squared next, and 2 squared is 4. So this comes out to be 3 times 4, which is the ultimate answer of 12 that I knew I was shooting for. Again, I'm just trying to get there by hand if I can, and trying to minimize the use of my calculator. 26 is a lot like the last problem. It's actually even a little bit easier in some sense. I'm going to make the negative exponent positive by dragging the 1 up to the numerator. Might as well figure out what the answer is first, though. So 1 over 125, exponent fraction, negative 2/3. My calculator, negative exponents doesn't slow it down a bit. So if I'm using my calculator, I'm going to try to enter the original problem in. So this equals to 25. Trying to get to 25. I'm going to bring the term from the denominator up to the numerator to make its negative exponent positive. I don't really need the 1 times, because 1 times anything is itself. So I could just write this as 125 to the 2/3 power. I don't need the 1 times. It's not necessary. Now I'm going to make a radical. I'm going to get the cube root of 125 squared. I need to do 2 things. I need a cube root and a square. So for this, first, I'm going to do the cube root of 125, and then I'm going to square. So again, the cube root of 125, I can do on my calculator if I don't know it. The cube root of 125 is 5, because 5 times 5 times 5 is 125. So this reduces to 5 squared, and when you square the 5, you get the 25. And the 25 is the ultimate answer. 28 doesn't have a negative exponent, so I don't have to make a negative exponent positive. Let me enter this again. Parentheses, fraction 8 over 27, parentheses, exponent, fraction 2/3. So there's 8 over 27 to the 2/3 power. This is supposed to equal to 4/9. To get from the problem to the 4/9 answer, I'm going to write it as a radical. As a radical, it's the cube root of 8 over 27 squared. I'm going to do the cube root first. So I'm going to do the cube root of 8 and the cube root of 27, and then I'm going to square. So cube root of 8, shift cube root of 8 is going to be 2. Cube root of 27 is going to be 3. So once I change the 8 to a 2 and the 27 to a 3, I drop the cube root symbol, but I don't drop the square symbol because I haven't squared yet. So this turns into the fraction 2/3 because cube root of each of the numbers is 2 and 3. And now I'm going to square. And to square this, I just square the 2 in the numerator, square the 3 in the denominator. 2 squared is 4, 3 squared is 9. So I've constructed a path from the original problem to the answer, minimizing my calculator use. I could do this whole thing without a calculator because I know every one of these facts without a calculator. I have a negative exponent. Need to make the negative exponent positive. This uses a rule that we haven't brought back up that we learned from section 4.2, that if you have a negative exponent outside a fraction, you can flip and take the reciprocal of the fraction to make the negative exponent positive. I'll get to that in a second. I'm busting this out on my calculator. So there's 81 over 16 to the negative 3/4 power. This is supposed to equal to 8 over 27. So by hand to get there, I'm going to need positive exponents and radicals. Fraction exponents and negative exponents I have a hard time doing without a calculator. First step, make a positive exponent. If you have a negative exponent outside of a parentheses, You can change the negative exponent to positive if you take the reciprocal of the fraction. So I flipped the 81 over 16 over, made the negative 3/4 positive 3/4. Now I'm going to write a radical. This is going to be the 4th root of 16 over 81 cubed. Now I'm going to do the 4th root and then I'm going to cube. So I'm going to do the 4th root of 16 and the 4th root of 81. The 4th root of 16 is 2. The 4th root of 81 is 3. So I can drop the radical by changing the 16 over 81 to 2/3. But I haven't done the cubing yet, so I'm not going to drop the parentheses. So this reduces to 2 over 3 cubed. To reduce this, I have to cube the 2 and cube the 3. 2 cubed is 2 times 2 times 2, which is 8. 3 cubed is 3 times 3 times 3, which is 27. So I've constructed a path from the initial problem to the answer using positive exponents and radicals. And that's what my goal was. So that's the middle group of problems. The middle group of problems is supposed to inspire me to figure out how to do the first 6 problems. The first 6 problems ask me to take the problem that has a fraction exponent and write it in radical notation. This is exactly what I've been doing for every single problem that I've done so far. I had a problem with a fraction exponent. I took that problem, wrote it with a radical, and I simplified. In this problem, I just want to write as a radical and then don't simplify. It's mostly these don't simplify, so I just want to get comfortable writing with radicals, things that are maybe slightly more complicated. This is a little more complicated than any problem that we've seen, but I can still write it with a radical. So problem 2, this, if I did it on my calculator, it's probably going to be an ugly decimal. 2 to the 3/4 power equals a horrible decimal. So it isn't something that I could simplify without my calculator. The only kinds of things I can have a chance of simplifying without my calculator are those things that don't come out to decimals. But I certainly can follow the instructions. The instructions just say write this as a radical. As a radical, this would be the 4th root of 2 cubed. The 4 becomes the index, everything else becomes the radicand. Since it says do not simplify, I'd have to accept this as an answer. It's probably better if you wrote the 2 cubed as 8. This is probably a better answer. It's not really simplified in that I didn't get rid of the radical. So I wouldn't really consider it simplified. It's just written differently. Simplified is what I was doing, the steps, when I took the steps to take the radical and get rid of the radical. In order to simplify this, I'd have to know that the 4th root of 8 is 1.68179281, and I just don't know that, so I couldn't simplify this without a calculator. 4 is a little more complicated than 1 through 6 in that when I go to use the rule, anytime I have a fraction exponent, I write a radical. The denominator of the fractional exponent becomes the index, and everything else goes under the radical. And in this case, the whole 3y squared belongs under the radical because the 1/3 exponent applies to the entire 3y squared and not just to the y squared. Again, this is what I would consider an okay answer. I definitely couldn't simplify this because I don't know what the y is equal to, but probably a better answer would be to write this as the cube root of 3y squared without the exponent of 1, because you just don't need an exponent of 1. It's implied. anything to the first power is equal to itself. So if I'd written that without the parentheses with the exponent of 1, it's a better answer. But they're both correct, especially because the instructions specifically say do not simplify. Then anything that I'm doing extra is technically simplifying. So I did more than I said, but neither one of these did I write without the radical symbol. That's kind of what I meant by do not simplify. Don't attempt to get rid of the radical, because either you end up with a decimal or something that you don't know how to reduce. Oof. 6 in this grouping is a horribly messy problem in terms of the and simplify part, but writing it as a radical is not that hard. The 7's going to become the index, so I'm going to write a radical, and then I'm going to write 2xy over 3z squared all cubed. Again, this is what I consider an okay answer. Because the instructions say do not simplify, if you didn't go further, it's okay. It would be nice if you remembered how to simplify without dropping the radical would be nice. But if you left it there, it'd be okay. It would be better if you realize that inside the parentheses that it could reduce to 2 cubed, x cubed, y cubed over 3 cubed, and z to the 2 times 3 power, using a simplifying strategy we had in section 4.1. So the reason we did 4.1 and 4.2 when the problems were a little bit easier is that you would have those skills and be able to pull them out when the problems are more complex. And we're heading to even more complex problems real quickly here. So the better answer, or probably the best answer, in terms of writing with a radical notation, would be the 7th root of 8 x cubed y cubed over 27z to the 6. But I would take either answer because of the nature of the instructions. The next group of problems has me go backwards. Each one of these problems has a radical, and I'm asked to write that radical with a fraction or a rational exponent. If I look at the instructions, it says write with rational exponents. Rational and fraction are they're interchangeable words. They have the same meanings. So I look at the problems, they have radicals. I'm asked to write them with fraction exponents. Whereas the last problems that we did, it says write in radical notation. They had fraction exponents. I'm asked to write in radical notation. These problems, they have radicals. I'm asked to write with fraction exponents, and it's just doing the backwards. So I'm going to unwrap this. I'm going to create a fraction exponent. The index becomes the denominator of the fraction exponent. Again, this says do not simplify. So because the instructions say do not simplify, this would have to be an okay answer. I give you full credit. It would be better if you wrote this. I'm not getting rid of the fraction exponent. I'm just writing something that's equivalent to it. But I'm not writing a problem without a fraction exponent. So I'm just doing a basic simplification that's supposed to be obvious. 10's a little bit different. This 2 in front of it makes it harder. So 10 really means 2 times the cube root of y. So the 2 is separate from the radical. It's not going to be joined into the fraction exponent. And better yet, I might have to think of this as 2 times the cube root of y to the first, because if I'm going to write something without a radical and I'm going to create a fraction exponent, I need to know both the numerator and the denominator. I knew the denominator. The denominator of the fraction exponent is always the index. But the numerator has to be the exponent that's under the radical. And so the numerator is going to be 1. And when I go to write this, I'm going to write this as 2 times. I'm not going to write the times symbol anymore. Y to the 1/3 power. With or without the times symbol between the 2 and the y to the 3rd, it means multiply. I just emphasize the times symbol just to really separate the 2 out, to try to emphasize that it's not going to have the fraction exponent apply to it. The next problem is a similar problem. It's a cubed root, and there's a 2, but the 2's in a different place. Because the 2 is in a different place, it's going to simplify differently. There's multiple ways to simplify this problem, and I'm just going to do one of them, and it's the one that I've had the most success with. So we'll notice in problem 10, the 2, because it wasn't under the radical, doesn't get a fraction exponent. In problem 12, the 2's under the radical, so it needs a fraction exponent. So 12 is a step up in difficulty of anything that we've done so far, but it's not anything that's going to be impossible. So I'm going to write 12 without a radical and using fraction exponents. Everything under the radical needs to have a fraction exponent to indicate it's under the radical. In problem 10, the y had a fraction exponent because it was under the radical. The 2 was in front of the radical, it didn't get a fraction exponent. In problem 12, I have to think of this as the cube root of 2 to the first x to the second, because I want anything under the radical to get a fraction exponent. So both the 2 and the x, because they're both under a cube root symbol, they're going to get a denominator of 3 for their exponent. So when I write this one, I'm going to write this as 2 to the 1/3, x to the 2/3. So when you look at the 2 here, 2 to the 1/3 tells me the 2 is under the radical. Here, 2 doesn't have an exponent. It tells me it was in front of the radical and not under the radical. That comes up on my test very frequently from this section. So I'm going to do 2 more problems, not from the handout. So this is just an extra bonus problem. So this is just extra 2 extra problems. Same instructions. Meaning write these with fraction exponents. And I basically made 2 of potentially the same problems, but definitely not the same problems. Both of these are square root problems, so I have to know that the index is 2. And anything under the radical is going to need an exponent if I'm going to take the time to write a problem with a fraction exponent. Everything under the radical has to get a fraction exponent. This top problem, I would write it as 3x to the 1/2. And the 3 doesn't get a fraction exponent because it's not under the radical. It doesn't deserve a fraction exponent. In this second problem, I'd write this as 3 to the 1/2, x to the 1/2. And immediately this tells me both the 3 and the x are under the radical, and the 2 tells me it's a square root. So the last 2 problems that I did kind of illustrated the same thing with the 2's. We had one with a 2 in front of the radical. The 2 doesn't have an exponent. The 2 under the radical. The 2 gets a fraction exponent. And then in these 2 problems, the 3 in front of the radical, in my rewrite, the 3 doesn't have a fraction exponent. The 3 under the radical, in my rewrite, the 3 gets a fraction exponent. Virtually guaranteed that somewheres on the test, being able to do the correct rewrite, taking a problem with a radical and writing it with a fraction exponent, one of these 2 is going to come up, and so many times students just get the wrong version. Let me just do even another one. Let me do this. 4 times the 5th root of x squared y, or the 5th root of 4x squared y. Both of these I want to write with fraction exponents. For this top problem, only the y needs to get an exponent attached to it. In the bottom problem, the 4 and the y do. Top problem is going to equal to 4x to the 2/5, y to the 1/5. Bottom problem, because the 4 is under the radical, it's going to be 4 to the 1/5, x to the 2/5, y to the 1/5. So again, you can see in my answer how an answer appears if the number, the integer, is outside the radical or under the radical. There, the 4 didn't have a fraction exponent. I knew it was to the left of the radical, not under the radical. Here, the 4 has a fraction exponent. I know when I go backwards, I'm going to see it under the radical. All right, so hopefully you don't get stumped on the test when I sneak that problem on there, because I do it almost every semester. The next group of problems, 31 through 44, I think that's the end of the section too. No, there's a 45 through 52, but they're just using your calculator. So some of the problems between 31 and 44 have letters, some don't. The problems that don't have letters, I can mindlessly press buttons on my calculator to get the answer, and I'll do that. And I'll try to follow up by confirming my answer by hand. So 32, mindlessly press buttons, but I might need to introduce a times between the 3's. So I'm going to do 3 fraction exponent 2/3. I'm not sure if I don't put a times in it, if it'll understand I'm multiplying these. So just for safety, I'm putting a times that isn't in the handout, but I believe it's okay. It's not wrong to do it, just emphasizes that I'm multiplying these. So this whole thing is supposed to equal 9. So how would I get there if I didn't have the calculator? Well, what I would realize is this is a problem that's similar to section 4.1. I'm multiplying terms that have the same base. And if I'm multiplying terms with the same bases, I add the exponents. So this group of problems is a complete, just almost a redoing of sections 4.1 and 4.2 with the fraction and the negative exponents that makes it harder. Now, I have to have the ability to add fractions. These fractions are easy to add because they have the same denominator. And when you're adding fractions with the same denominator, you just add the numerator. So 2/3 plus 4/3 stays in the exponent, turns to a 6/3. 6/3 is 2, and 3 squared is the 9. So I could simplify the problem using the rules of exponents that I know. Write my final answer with positive exponents. I wrote my final answer without an exponent. That's even better. 34, my calculator can't help me on 34. So this is a problem that only has positive exponents, means it only has the skills from section 4.1. I'm dividing terms with the same base. If I'm dividing terms with the same base, I know I'm subtracting the exponents, and I know the letter needs to wind up where the bigger exponent is, because the bigger exponent's in the denominator, the y's going to wind up in the denominator. So to do problem 34, I would do that. I'd form a fraction. I know that my answer has to be a fraction. The y's going to wind up in the denominator. Subtract the exponents, and when I subtract the exponents here, really just have to subtract the 4 and the 2 because the denominators are the same. And I could write this as 1 over y to the 2/3 power, and that would be the answer to problem 34. So these problems get to be insanely hard if you don't have sections 4.1 and 4.2 mastered. Quite honestly, I don't think they're going to be a big focus on the test. So if this is a really baffling group of problems for you, you will still at least be able to get a B on the test. If you can't do this group of problems, it might be hard to pull off an A on the test if you couldn't do any of these problems. 36, I've got the same issue. I'm calculator not friendly because of the y. Again, this would just be the kind of problem we did in section 4.1. I'm going to cube the 5 to get rid of the exponent. And for the y, I'm going to multiply its exponent by 3. I'm going to do both things on my calculator. I'm going to cube the 3, and I'm going to multiply 2/3 by 3 on my calculator. Cube the 5, should I say. So first I want to do 5 cubed. I know that that's 125, but if you didn't know that's 125, you could definitely pull that out of your calculator. And now I'm going to work on that exponent for the y. If you don't know how to multiply 2/3 times 3, you can do it on your calculator. So I'm going to do 2 over 3 times 3. And my calculator tells me that that's just 2 and it's not a fraction, so I'm going to get y squared. If I wanted to do the 2/3 times 3 by myself, I'd consider this 2/3 times 3 over 1. I'd cancel the 3's, and it comes out to be 2 over 1, which is just 2. But if you couldn't do that multiplication in your head, I'd just do it on my calculator. So the answer for 36 is 125y squared. Oh, negative exponents. But negative exponents, but not letters. So I can absolutely do 38 mindlessly. So I'm going to do it mindlessly to pick out that answer. So I'm going to go 9, up arrow, fraction, negative 1/2. I'm going to do a times sign again. I didn't have the times sign in the right place. I don't know what I entered there. I'm going to try it again. 9, exponent, fraction, negative 1/2. Double right arrow to get out of the exponent. I'm going to put a times sign in that I might not need, just like I did in the first problem in this group. And then 9, exponent, fraction, 5/2. So that looks enough like this problem that I'm going to hit enter and believe the answer is going to be 81. So I'm going to try to get to 81. Lots of ways to do it. I'm going to use the rules of exponents to make the negative exponent positive because I do better with positive exponents than negative exponents. I'm going to take this 9 to the negative 1/2 and drop it down to the denominator of a fraction and make the exponent positive. I really didn't have to do that, but I liked doing that because I don't work well with negative exponents. I do way better with positive exponents. Now it's a division problem, so I know I'm subtracting the exponents. My answer is not going to be a fraction because the bigger exponent's in the numerator. So I'm going to subtract the exponents, not have a fraction, winds up as a non-fraction with the 9 in the numerator, no denominator necessary. Now I'm going to subtract 5/2 minus 1/2, so I'm going to subtract the 5 minus 1 and get 9 to the 4/2. 4/2 easily reduces to 2. This comes out to 9 squared, and 9 squared is 81. So I've constructed a path to get to the answer, even if I didn't have a calculator that smoked on these fraction exponents. $40, toughish problem, negative exponent I need to make positive. I'm going to take the y to the negative 3/4, drop it down to the denominator to make its exponent positive. That's going to leave me with a fraction without a numerator. I can't have a fraction without a numerator, so I need to leave a 1 behind. So I'm going to write this as 1 over 6 y to the 3/4 for the y from the denominator, and then the y from the numerator is another y to the 3/4 in the denominator. It would be better to write the answer with 1y as opposed to 2. Since the y's are on the same level, they're being multiplied, and I'm going to add their exponents. I'm not going to do anything to the 1 or to the 6, but for the y's, I'm going to go from 2y's to 1y by adding their exponents. And again, those are easy fractions to add. 3/4 plus 3/4, I add the 3's, leave the 4's alone. So this is going to be 1 over 6 y to the 6/4 power. And I'm going to reduce that to 3/2. So I'm going to say this is 1 over 6y to the 3/2 because 6/4 reduces. I'd stop there. This for me would be my answer. This is correct. It doesn't have a radical. If you wanted to have a radical, you could. The 6 wouldn't belong under the radical because it doesn't have a fraction exponent. But if you wrote this as 1 over 6 times the square root of y cubed, whether you wrote the 2 or not, this is an okay answer as well. But I'm not expecting you to take fraction exponents and make them into radicals unless in the instructions it says write the problems with radicals, and it doesn't say that in the instructions. 42, it's not a fun problem because of the letters. My calculator can't do it. Fractions make it hard. Negative exponents make it hard. For me to attack 42, I don't like the negative exponents. I'm going to make the negative exponent positive by creating a fraction and tucking the term with the negative exponent into the denominator of that fraction. I'm going to cheat now. Well, not cheat. I'm going to be lazy and use my calculator. I know that I'm dividing, so I'm subtracting exponents. 2 is bigger than 2/3 because 2/3 is less than 1. So I'm going to subtract the exponents. My answer is not going to be a fraction. What's going to be left is in the numerator. And so my answer is just going to be b to some power. And to do that, I'm going to go 2 minus fraction 2/3. And 2 minus 2/3, if I do that, is 4/3. So my answer is going to be b to the 4/3 power. If I wanted to do the fractions by hand, what I did is 2 minus 2/3. By hand, I think of this as 2 over 1 minus 2/3. And then I'd multiply the 2 over 1 by 3 over 3 and get 6/3 minus 2/3. And that's how I can get the 4/3 if I didn't want to use my calculator. But since I have a calculator that does fractions so well, this seems like feels like a waste of time to me. It took me 3 steps to get from the subtraction to the answer when I could have just pressed buttons, and I'm content with you doing fraction work on your calculator. You don't have to do the fraction work by hand. Last problem in this grouping, another messy problem, negative exponent that I need to make positive. To make the negative exponent positive, I'm going to bring the y up to the numerator. When I bring the y up to the numerator, I get y to the 1/2 times y to the 3/5. Now I'm multiplying, so I need to add the exponents. This is going to be y to the 1/2 plus 3/5. Again, my calculator adds fractions so nicely, I probably wouldn't do this by hand. I'm going to go 1/2 plus 3/5, and the exponent's supposed to be 11/10. So I'm going to write for my answer y to the 11/10. If you wanted to do the fraction work by hand, the 1/2 you're going to multiply by 5 over 5 and make it y to the 5 over 10. The 3/5 you're going to multiply by 2 over 2 and make that 6 over 10, and then you're going to add the 5/10 and 6/10 to get the answer of 11/10. 45 through 52, it says just do these on a calculator. Again, I wrote this problem set, I don't know, probably 5 years ago now. And 5 years ago, using your calculator was a monumental task. So I have these calculator problems sprinkled through this chapter and a lot in chapter 6. But so hopefully you could smoke through these. And one of them comes out to be a fraction. The rest I'm just going to round to 4 decimal places. And I can enter the problem just like they are. So the first one, I'm going to go 5 exponent fraction 1/3. And I get 1.70997. So I'm rounding to 4 decimal places. This is hard rounding. This is pretty advanced rounding. Hopefully you can figure it out. But it's not easy if you're not comfortable, if you don't round regularly. So this 7 tells me to round that 9 up. It rounds up to a 10. I carry the 1 over to that 9, rounds that 9 up to a 10. I carry the 1 over to that 0, and it makes that a 1. So technically, if I wanted to round this to 4 decimal places, it's 1.7100. Usually you don't write zeros, and it would be adequate just to write 1.71 because these are non-significant digits, I think. I last time I took chemistry was in high school. I got a C in chemistry, so I don't remember the significant digits. So those of you that are in chemistry, I might be talking complete nonsense because I really don't remember that. But this is definitely okay. It's okay to not have the 2 zeros at the end. It's still considered rounded to 4 decimals. You don't need to put these insignificant digits. The next one actually is going to come out to a fraction. And having it come out to a fraction means there's a way to do it without my calculator if I want to push myself. But it tells me to use my calculator, so I'm going to just use my calculator. And this one I get 1 over 343. I prefer fractions to any decimal, so I'm not going to change that into a decimal. 50, the square root of 2 cubed, square root of 2, exponent 3, Oh, it's 2 square root of 2. I want that decimal version, so I hit SD, and I get 2.82842. I look at the number in the 5th position if I'm going to round to 4 decimal places. That tells me I don't need to round the 4 up. I could just leave the 4 a 4. And for an answer, I'm going to write 2.8284 for problem 50. 52 on some calculators is an unbelievable task to enter, but on this it's not. So I'm going to go shift radical with the exponent. So with the index, there's 5, and then 4 exponent fraction negative 2/3. Looks enough like that problem. Enter. I get 0.83123. I don't care about anything after the 5th position. If the 5th position is 5 or higher, I round up. If the 5th position is 4 or lower, I don't round the 4th digit. So I'm going to leave that 4th digit a 2. So I'm going to get 0.8312 for my rounded version of this. I hope that's the whole section. This is a meaty, tough section, so you're really going to have to hit it hard. And if this middle group of problems, or the second to last group of problems I did, baffled you a bit, it's probably because you just don't know sections 4.1 and 4.2 well enough to translate those skills into the harder problems. And you might want to relive 4.1 and 4.2 before you attack these problems. Yeah, that is the whole section. So we're almost to the halfway point in this chapter, and more often than not, I give 2 50-point tests over chapter 4. So likely, after we get done with sections 4-5, we're going to have a test worth 50 points covering all the problems from sections 4.1 through 5, nothing from 4.6 through 4.10. And then after we do the first 50-point test, I'll lecture on 4.6 through 4.10, and that topic, those stuff will be, the material covered in there will be on the second test, more than likely. Check your syllabus or ask me if every now and then I don't have the time and I make that not happen, but 9 times out of 10, expect a 50-point test after section 4.5. All right.